Welcome to Slight Reliability, the show where we learn about reliability, observability, and resilience one day at a time. I'm your host, Stephen Townsend. Welcome back to Slight Reliability. I'm Stephen Townsend, and this is the show where we learn about SRE and observability and all kinds of other things a day at a time. Today, I'm joined by Checo, who's been building websites for over 25 years and working in enterprise software development for almost 15. He was the lead product manager at Acquia, managing over 10,000 live sites around the world. And he led product innovations at New Relic before co-founding 2 observability AI startups, including his most recent endeavor, Ottermon AI. How are you today, Checo?
I'm doing great, Stephen. How are you doing?
Really good. As always with these recordings and time zones in New Zealand, I do these very early in the morning for the most part, but it's quite nice to start your day with a conversation about something interesting. Yeah.
Oh, absolutely. I mean, I can think of far worse ways to start my day, like with an alert.
So tell me a little bit about Ottermon. What's the idea behind that? What are you working towards?
Yeah, absolutely. So, Ottermon came about from my experience early on in tech support at a hosting company. We essentially on our team at the time, we saw the same types of outages over and over and over again. And a lot of them we were able to eliminate over time by improving our documentation, by improving the product, by giving customers access to more features. But once we got to a point where the platform was auto scaling and every customer had access to monitoring, we were still seeing, customers take themselves down 25, 30, 40 times a day. And what we realized is that there's a lot of flaws in the system, right? That you have brilliant people on these development teams who are releasing code and not realizing that the way they're building the site, the way they're architecting it, the changes they're making are setting them up for pain down the road. So for us, at that point in my career, we had to create tooling on top of monitoring to identify those symptoms, those signals early. And that allowed us to be more prescriptive with our recommendations. And that's where we learned that if you're actually focused on preventative monitoring, you can stop most outages, right? It's a combination of a little bit of prevention, a little bit of good CI/CD, but you can accomplish a lot with the right data interpreted the right way. So, I ended up, as you said, I went to New Relic. I learned a lot there, talking to our customers and experts. And that's where I saw there was a lot of pain with companies. I saw one customer said, I send you all my data and I spend thousands of dollars every month. Why can't you just tell me what's wrong and how to fix it? And that always resonated with me. So when I left the company, I found people who were like-minded, who had been dealing with this at some of the biggest companies in the world. And what we realized is that we were all solving this problem the same way. We were putting logic on top of monitoring to find these problems, these risks, these optimization opportunities for us. And that's how we came up with Ottermon AI. Essentially, we realized that you don't need full fleet monitoring and 100% of data granularity to prevent or solve these problems. You can do it with a small amount of data and the right logic. And that's how we eventually founded the company.
Okay. So I think it was the observability engineering book, or I read so many different things, I lose track of where I learned a thing from. But there's a lot of talk in many of the things that I've read and consumed about knowns, known knowns, unknown unknowns, known unknowns, those kinds of things, right? So when you're talking about having observability, you've got your monitoring, you're collecting all kinds of events and telemetry, and you're putting some kind of logic on top of that to find, to in advance find, there's something weird happening here, or this looks like you're concerned, or this is going to be a problem soon, or even after the fact, this is a problem. Does that work in the world of known unknowns or unknown unknowns? Like, can it detect things which we could have never possibly have predicted because we've never seen them before? Or is it more, Yeah,
that is a really good question and a good way of framing it. The way I see it is there are thousands of teams around the world building websites, building mobile apps, APIs, using Kubernetes containerization, right? And these teams are working in isolation. And if somebody on that team happens to read a blog post or an article and they hear about other ways sites have gone down or platforms have gone down, maybe they'll implement that change. But there is no source of collective knowledge right now. And there's no easy way to find the signals in the noise that indicate the risks that these people are facing, these teams are facing. So for us, I would say this is more of a known unknowns, right? Somebody out there has probably experienced the exact same problems you faced or the problems you're about to face, the things that are going to wake you and your team up or interrupt your sprint, right? Somebody has probably faced those before, no matter how bespoke your architecture is. So if you're able to take those and build those into a system and have it say, look, this is how you spot the early signs that this is the direction this team is going in. Maybe start escalating the ways that other teams have started preventing those types of issues so that it can be worked into a sprint or a quarterly roadmap plan instead of something that wakes someone up in the middle of the night or pages mid-sprint.
I guess it's a bit of a segue. Let's say one of the things we wanted to talk about is what you described as the observability lifecycle for DevOps teams. And I didn't immediately understand what that meant, but are we talking about what the journey from going from absolute no observability or the base level collection of metrics that come from whatever we've already paid for and haven't configured it all, through to we actually understand the behavior of our systems, the key, the health of our services, we're able to diagnose things quickly, that kind of thing. So is that what you meant by that?
Yeah. So this is something I've seen play out literally thousands of times at different companies, right? So many start out really simple, right? The typical startup mentality. I've got a CEO and a tech founder, and we're going to go out and try and change the world. And you innovate, you use bare minimum monitoring for as long as possible. And then inevitably at some point, right, the team will start to grow, the complexity starts to grow, the criticality of the system starts to grow, and you can't afford to have issues. So, there's two camps this early on. There's people who have done this before and people who haven't. People who've done this before, they will either know what monitoring to implement and, try and get something in there, the bare minimum they need. And then there are people who just don't know better and they default to best practices. They'll say, I'm going to go do Grafana self-hosted, Prometheus, CloudWatch, something, right? But it always starts off relatively simple in a perfect world, right? In a typical world. And then you tend to see this evolve over time where issues are missed. Incidents happen, something breaks that wasn't supposed to. We don't have the right type of monitoring for that, or we need to have more monitoring. We need a different vendor. I don't like this vendor anymore. They're too expensive. They're not robust enough, right? You start getting into those discussions, and that's how you end up getting into this cycle of more monitoring, more tools. A lot of the companies I speak with have Grafana, Prometheus, they have CloudWatch, they've implemented Datadog, New Relic, Sentry, some amalgamation of services just in the monitoring sphere, not just security monitoring or cloud cost monitoring. So now as you get a certain degree of maturity, you start seeing more tools that teams have to work across to figure out what's wrong. Is the system healthy? How do I fix that, right? But then things start to escalate from there. As companies get bigger, they have a bit more budget, more complexity, more risk. A lot of times you'll have somebody comes in who says, hey, we can't afford these lower end, and I'm using their quote, right? Like these lower end solutions anymore. We need a premium enterprise. We need to go with Splunk. We need to go with Datadog, Dynatrace, right? And that's where you end up in a world where now somebody's coming in and championing for something that's better and more powerful, more trustworthy, right? You want this all-in-one solution that'll fix all these problems. And I'd probably say 6 or 7 out of 10 cases, that person leaves before that vision is ever brought to fruition, right? So what ends up happening is they start implementing this other solution, this enterprise thing, and most of them never actually get rid of the old stuff. So, it's very expensive. It's very time consuming. It requires a lot of expertise. It's money, time to get these things in. So a lot of times these companies do not consolidate onto one vendor, which leaves them with N+1 solutions. Now they get a little more mature. They grow. They start acquiring things. Now they're stuck with the monitoring that their acquisitions had, or their teams are so sprawling that they don't want to wait for the politics of the business to approve, more funding for this other tool. They'll go create their own thing, or they'll bring in some smaller solution. Now you've got this epic sprawl, right? You end up with a company like Cisco, where Cisco owns how many monitoring solutions? But like, if you talk to them, if you have any friends that are working at Cisco, they'll say, we don't use the things we bought. We've got all these different solutions in place. And that's what you see at so many large companies. This consolidation is hard, even when you have the experts, even when you have the time and the money, because it's hard, right? So that's typically the life cycle we see. And then there will always be a case for, can we try and consolidate? Somebody will come in and make the case it's too expensive. We're looking across too many tools. We don't have unified visibility, and they'll always try and consolidate. And the cycle just continues over and over.
That's interesting. So our organization right now, one of the things that we're actually trying to tackle that a bit, we do have a few different observability tools, at least 3 big platforms that we pay for. And one of my colleagues talks about swivel chair. At the moment, we've got to, you got to go to this tool, go to that tool, go to that tool to get the full.
Yeah.
Right. And so I think open telemetry is an interesting opportunity, I think, and we're looking at it as an organization to say, all right, let's accept the fact that there will be lots of tools, right? But what we can do is have some kind of centralized ingestion and storage of telemetry, and then we just ship it out to wherever we want to sort of work with it at that point. But I think that's probably pretty common. It's very new to me because I haven't actually seen it implemented before. But it's essentially putting telemetry data in a more traditional data warehouse or data lake kind of situation, and then using OTel to sort of take the bits you want and putting it in the tools you want them for particular use cases. Before that, anything like that?
Oh yeah, absolutely. So, if you step back and you look at the observability ecosystem today, I like to contextualize it into 4 buckets, right? So you've got telemetry generation, and that could be your traditional solutions like syslog, collectd, open telemetry, right? The things that create the telemetry data that goes to these vendors. So you got the telemetry generation is point 1. Then I'm going to go right to point 3 for a second. You've got these all-in-one vendors or these monitoring solutions. They're essentially data lakes or data warehouses, whatever you want to call them, right? They ingest, they render, they allow you to query, to alert on your data, to try and understand it. Because of the challenges associated with both of those things, you've ended up with bucket 2 and bucket 4. Bucket 2 are these telemetry pipeline solutions like Cribble, Control Theory, Edge Delta, right? They sit in the middle and they're saying, you know what? Pass your data through us. We'll help you route it. We'll help you transform it, enrich it, sanitize it, standardize it, do all the things you need to do so that when it goes where it needs to go, it's secure, cost-effective, informational, right? And then the 4th bucket are these kind of emerging tools, these SRE AIs, these RCA AIs, right? These agentic solutions that bolt on to your all-in-one provider. And they're trying to help you understand your data, understand your infrastructure, identify issues, diagnose them quickly, resolve them quickly, right? And that's the ecosystem that exists in observability today. So you're always going to see these different flavors of those 4 things. There's companies out there trying to improve data generation, like not just with OTel as a non-vendor, like open source, non-proprietary solution, but trying to figure out ways to play in that ecosystem and improve the way telemetry is generated, right? There's lots of issues around telemetry generation. You're creating too much noise, not enough, et cetera. People are looking at, how do I make sure the right signals are coming out at the right interval and not sending data unnecessarily? The pipeline solutions, you've got the ones like Cribble that are trying to help you finesse where things go and how they look and the information inside them. But then you've got like a control theory that says, I'm going to try and take the stuff that's flowing through, look at how it's being used at the endpoint, and then I'm going to throttle it at the source, right? They're trying to help be that kind of coordinator, that traffic director. And then these endpoint solutions, these all-in-one vendors, are trying to kind of play a little of everything. They're developing SRE AIs. They're developing some degree of pipeline functionality without, risking their bottom line, their quarterly growth. They're trying to maintain the dominance of their proprietary agents while playing nicely with OTel. There's nuance and there's subtlety in all of these things, but it all speaks to the 2 primary problems in observability, being you're either generating too much data or not enough at the source, and it's not generally adaptive. And then once all that data is created, we spend too much time managing it, too much time trying to understand it. And what would happen if we had intelligent systems that could interpret it for us and just tell us, here's what you need to know, where your problems are in priority order, and by the way, what caused them and how to fix them. That's what it feels like observability is moving towards now.
I work for a really big enterprise, and one of the things that is happening in our org is that there are kind of monolithic or really important systems of record that have traditionally been the kind of on-prem systems. And rather than just like getting rid of them or running our own microservices, we fundamentally we're an insurance business, right? We're not a software vendor. So we do still purchase products for, to provide key technology services. And some of those traditionally on-prem services are going into the cloud. I'd call it sort of a mix between a SaaS and a PaaS kind of situation. And as part of that, it's like we have a little bit of visibility into what's happening in those systems, but it's limited, right? Because that's part of the cost of giving up. You're going to worry about the infrastructure now, Have you seen that kind of thing impacting how effective observability can be in big enterprise? Or is that just a thing that I've noticed?
No, I mean, I think it's fair. There are always going to be trade-offs, right? There's trade-offs when companies choose to host on-prem versus in the cloud for themselves. There's trade-offs when they choose to use a vendor that's on-prem or in the cloud, or like in that customer's cloud versus in their own cloud, right? Some of these vendors, you look at like CloudFuse, they say, we'll help you host your own data lake, right? It's not our data lake like a Datadog or New Relic, it's your data lake, right? So it's all about what the business really cares about and the sacrifices they're willing to make. We have all these laws in the US. We have FedRAMP for federal government organizations. In Europe, they have GDPR, right, about data sovereignty and don't let it leave. But there are all sorts of gray areas and exceptions that companies will make if they're concerned about cost, if they're looking for ways to work around limitations to just have a solution that works, that gets them to market faster, that solves a pain point faster. Right. So that's how you have so many European companies using enterprise observability solutions today, despite the fact they're mostly hosted in the US, right? And kind of flies in the face of the whole GDPR initiative. But for those businesses, they're willing to make that exception. So you will see, what you're talking about, even at the level of, where are we hosting our own data? Is it something that we have in physical security and physical devices in a building somewhere? Or have we trusted it to our version of the cloud such that we know it's behind a VPN and a VPC and all these different firewalls, right? Or, this is too expensive for us. We'd have to hire too many people, too much labor, whatever. We're just going to let the enterprise do it. There's always going to be that trade-off. And yes, to your point, there's changes in how much visibility you get in those different scenarios, especially, like I said, so many companies have multiple vendors. In that scenario, you might have a much smaller bucket to choose from, and no one vendor does everything, let alone does everything well. So you end up making sacrifices in that way too.
Yeah. To your point about the need for the kind of what you're essentially building for Ottermon AI. So our organization had a strategic observability platform. The idea was move everything onto it. It's the single source of truth. We can get everything we need. We can see end-to-end tracing, all kinds of beautiful things. And then we chose a different technology. We chose a cloud-based technology for some of our core platforms, right? And they said, well, we provide you this other tool. You can't use your tool anymore. So then immediately that traceability, that end-to-end is broken. So you have to accept that. You can't just say, no, we must have one tool. You've got to find other ways to make it cohesive.
Yeah, I mean, the important thing to take away is there's a reason there are billion-dollar companies doing monitoring, right? These companies have teams of hundreds, if not thousands of engineers trying to solve these problems. Companies can absolutely figure out a way to make things work on-prem or in their cloud. They can do things themselves. They can customize tools to their use case. But then there's the question of, is this the best use of our budget, right? Do our requirements restrict us so much that this is just a sunk cost of the way we do business, that we have to have people writing their own code or having limited monitoring, et cetera, et cetera? Or can we adjust our business model and justify this in such a way that we'll have fewer people and few expenses that we are on the hook for as the customer, but now we've given up some control. We have some additional risk because this data or this functionality is with somebody else that we have to trust.
I'm going to ask a question. I have no idea how you're going to respond. What do you think of the idea of an observability maturity model?
So I've seen a number of frameworks online that talk about observability maturity. So if you're referring to the official one, I can't.
I don't know. There was an official one, so no, just in general.
Okay, all right. So the general concept of observability maturity. So let me answer that question with a story. So I work with a brilliant man out of the UK. His name is Andrew Maliband. He's an observability expert. He's worked at a bunch of different companies and also just speaks with all the different companies in observability. And I read his articles all the time. And one of the ones he posted, it's the only one he's ever posted that I had to push back on, spoke about how at a certain scale of the enterprise, to do observability right, you need to have, and I'm going to paraphrase a lot of this, right? You have to have a security engineering team, and you have to have a special observability team and SREs and all these folks that understand the different aspects of observability to make sure they're getting them right. And there are so many types of observability, right? Synthetics monitoring, real user monitoring, APM, infrastructure, logs, security, network, right? All these are, he was going on, his article went through all the different ways that you can monitor and how at enterprise scale, it requires forethought and planning and investment. And I remember having a conversation with him saying, this is the problem, right? The fact that observability requires detailed planning to the extent that you're doing dozens of headcount and hundreds of thousands, if not millions of dollars in planning, just to know if your business is online and whether or not it's broken, it feels like that is the problem, right? That is the fundamental issue with observability. But let's go back to your question, right? In terms of like observability maturity. Observability is as mature as you need it to be to get the answers you need to run your business effectively. And there are tens of thousands of websites out there that are perfectly content with a pingdom, just telling them if their site's up or down, right? There are people out there who are perfectly content just taking a look at their logs periodically and seeing an elevated error rate. But as your business grows more complex and as your needs necessitate that you have 99.99% uptime or maximum security, or else your brand suffers, your revenue suffers. Your teams are getting distracted away from innovation and towards maintenance and incidents, right? Unplanned work. That's where you do not have observability maturity, right? You are missing things that are, and as a result of missing them, they are keeping you from spotting the problems early enough to prevent them, right? Or to diagnose them quickly, or. So, it really depends on just you as a business and your team and your risk acceptance, your tolerance, and what you need to be successful and keep the business running without risk or distraction.
Let's talk about AI. So,
yes.
First of all, okay, so I'll start with, and I have spoken about this on the podcast before, when I think of automated observability, I have such a negative opinion because I think of enterprise tools that I've used in the past where an organization has implemented said tool and have not configured it at all really for their needs, haven't really, instrumented their code or provided it in business context. And you would go into a tool, or you'd get an alert email in the morning, like a summary with a bunch of anomaly detection stuff that just doesn't have any meaning or context. And it's just, this is a complete total waste of time. So that's when I think about observability and AI, that's the first thing I think of. And I'm sort of tainted by that. Give me a positive side. Like what are some of the use cases? How could it work?
Well, I mean, so it's let's frame the issue, right? So, we're seeing right now is very similar to what, I'm going to be generous and say, our parents saw when the internet, became more popular. I'm just going to say that was our parents' problem, right? Where people were creating a bunch of websites and they're like, oh, this will never take off. Look at this problem. Look at this issue. And I mean, 25 years later, the internet is essential to almost every aspect of life, right? You go back further than that. How many people were like, you know what, these motorized vehicles will never take off, right? I'm going to stick with my horse and carriage because they're so unreliable. They're not going to put a gas station on every corner. And so every new technology has growing pains, right? And I think we all agree that AI is imperfect right now, but let's look at why it's so essential at this point in time. There was a time when websites, and I mean, granted, there are still websites that do this, but there was a time when websites were hosted on a single machine, right? It was HTML and CSS and everyone was content. And the complexity has exploded over the past 30 years, right? Not just the adoption of microservices, but containerization and AI agents themselves. These architectures are becoming so complex that people cannot logically monitor them. Like they can't understand them. They can't process how data is flowing between these complex systems. So we're reaching the limits of what humans can reasonably do. A, B, these humans in general, we're frail, we're limited. We can't be up 24/7. We can't learn every best practice for every technology we're using. We can't learn the entire history of the products we're building and the platforms and the companies. Like as we move between companies and join engineering teams, right? We can't learn their entire history. So what do you do when humans are flawed and limited? You try and augment that with something that can learn everything, that can work in seconds, right? Instead of us taking minutes, hours, days to learn. So when we think about the fact that technology and human limitations are both forcing us to find a better, more efficient way, the first thing we do is say, what does better look like, right? And in a perfect world, better looks like I get to spend most of my day coding and I almost never get an alert. I should be so surprised by the sound of an alert that I actually have to stop and think about what that noise is. That's the ideal, because it should be so rare. So now you have to back into how you get there. Well, you'd ideally have a system that self-regulates, that knows what telemetry is necessary to tell something else whether or not it's healthy, and then something interprets that data and says, all right, well, based on what I'm seeing, you might have a little cold, fella. So I'm going to give you this medicine, right? Like I noticed that you're limping a little bit. I'm going to prescribe this crutch, right? That's essentially what we're doing is we are creating methodologies and layered logic that says, when you see X, do Y and then Z, and hopefully everything will get better. And again, if we go back to the perfect world, the system does that autonomously. It knows what signals to generate, it knows how to react to them, and it only notifies a human in the loop if something really needs a person's attention or this is super high risk. We're a long ways away from that, but that doesn't mean we can't push towards it. So now backing into your question, right? What are the use cases? Today it looks like I just need to understand things a little more quickly. Why have Checo as a software engineer go look in CloudWatch and Grafana and Datadog to try and figure out what's causing this anomalous error when I can ask the machine, hey, why is there an error? Sorry, my Boston accent's coming through now. Why is there an error in the microservices around payment processing right now? Oh, well, let me take a look. And, the system can go and pull some visuals, pull some context, right? It can do some initial analysis. You just save that person 10, 15, 20 minutes, half an hour. If the website's down, that's already accelerated things quite a bit. So, the drawback, as you noted, is it's not always right. Sometimes it hallucinates. It makes things up. There actually is no microservice that the system can detect, but it's just output a statistically likely response for data it can't access, right? So we are at a trust chasm right now with AI, and our responsibility as a community is to figure out how to cross that together to get to that promised land I mentioned at the start of my speech.
I do think, especially where AI is at the moment, we have a responsibility to provide it sufficient context. You can't just install an AI, whatever, and just say, fix the things for me. You have to. It's your job to understand your technology, your business context, your socio-technical system that's providing this thing, and provide enough context for it to actually work within it and do a good job. There's something else that so this is maybe going a little bit far, but there's something I think actually beautiful about what you said. A lot of my purpose in the work that I do, because I've been through really bad burnout in the past, is that I want to find ways to prevent suffering at work, right? Because the work we do is often very creative, it's often very satisfying, but man, it can be stressful at the other side of things. It can be unpleasant. So there's something about the modern era, the level of complexity that we work in it's just constantly ramping up. And I can feel it. Cognitive load is just at peak. So if we can find a way to leverage AI to take away some of that cognitive load so we can have actually, within that complexity, a simpler day at work and more enjoyable experience, I'm all for that. And it's really reframed my mind. Yeah.
Yeah, no, absolutely. I mean, here's the thing. A lot of us go into software engineering and these types of careers because, and especially in the SRE space, right? You don't go into that thinking that you're going to be a hero. You go into that knowing that the people on your team depend on you because you've been on their in their shoes. You have experienced the suffering yourself. You are trying to save them from what you went through, right? And so it takes a very special mindset. And it's often a very thankless job. I've literally written articles about how SREs, they go out there and they're just fighting the good fight thanklessly with the business telling them they're not doing good enough and the teams that count on them telling them they're not doing good enough. And still they're out there fighting, finding ways to stop the alerts, to get the right tools in place, to solve the problems that are causing people to lose sleep or get stressed at work, right? And, I feel like AI has the potential, if you look at the past 25 years, has our life gotten better since the old days of CheckMK and Nagios and Google Analytics and Pingdom, and the evolution of Datadog and New Relic, right? Has our life gotten better? We have more visibility. I don't know that many engineers feel like troubleshooting is significantly easier than it was before, but AI is starting to change that. If you look at the innovations coming out of Incident IO, Traversal, some of these other companies that are starting to automate the incident diagnostic process, it's lessening the pain. But, to your point, there's still challenges, there's still risks. And one of the biggest ones comes down to documentation, right? So this may be, a little bit of a surprise, but, you know, people right now are wondering, how do I make it so the AI is more reliable? Do I have to change the mathematical formulas? Do I have to pick the right vendor? Whatever. We're going to find that the reason AIs are unreliable is because things are not properly documented, right? If you think about when a human onboards to a development team, how long do they spend learning from the people that hired them, the other people on their team, digging through old Jira tickets or Confluence docs or pull requests? Not to mention, I mean, I will not guilt anyone for doing this, but how many to-dos are there still in code around documentation, right? But that is all lost context or hidden, obfuscated context that explains why the system is the way it is and helps people understand, the rationale behind how systems are built and how they work and how they break. And I think what we're going to find is not just an issue with the telemetry coming out of observability. Is it the right frequency or the right signal, and how is it interpreted? But until you can pull in that context, you will never be able to properly, in a bespoke fashion, customize these AIs to help individual companies at scale. And that's because these AIs can understand how everyone operates, but they can't necessarily understand why you operate the way you do. And that is going to require really robust documentation, architectural diagrams, things that people have fallen behind on at every company for all the obvious reasons. Within the next 5 years, mark my words, this is going to become an essential part of development because it is otherwise blocking the AIs from doing their job.
Which brings about a socio-technical problem that I've seen, is that a lot of engineers don't like writing documentation. I personally love it. There's something satisfying to me about, here is a technical thing, I'm going to write it down, and in doing so, I'm going to understand it better. And if I can, and I love the challenge of how can I articulate this in a way which other people can understand, even if they don't have all the context I do. I love that, but most people I work with are like, oh, here we go again.
But I feel like this is also, maybe this is an area, and I don't study CI/CD as closely as I study observability, but this feels like an idea for someone to run with, right? What if you had, a degree of intelligent self-documenting code, right? We're already starting to see the emergence of some degree of self-documenting code and self-unit testing code, right? But the notion that a system can look at your Slack messages, your Jira messages, and understand, you have to trust these systems, but understand that the reason you are coding this module or this functionality is because you're trying to achieve X. Let's capture that. If it's looking at what you're coding, before you do the pull request, it can ask you, hey, you haven't documented X, Y, and Z. Can you help me understand it? And I'll document it for you. Or I'm inferring from the way that you've coded this, you're trying to accomplish X, Y, and Z. And again, it's just another opportunity for how a human and an AI can partner together in a co-pilot fashion to create the downstream enablement that's necessary on the diagnostic and monitoring side.
So Ottermon AI is working in this space. What specifically how specifically are you tackling this, or what sort of problems are you trying to solve?
For us, we see, going back to the original point of our conversation, right? There are so many companies out there in two buckets. They either have a ton of observability tools that aren't playing nicely together, they're not talking to each other, they're lacking not just that cohesion of those telemetry, but the lack of that context we were just talking about, right? So on the one hand, you've got that bucket of customers and engineering teams. And on the other hand, you've got these younger, smaller startups and tech companies that have minimal monitoring or avoiding implementing anything beyond do-it-yourself monitoring, right? And in both of those use cases, there's a need. There's a need for something to just understand their data and tell them where to focus their attention. These are your issues, these are your risks, these are your optimization opportunities, in a clear and understandable fashion, right? So for us, what we're doing is saying, how do you even achieve that when there's so many systems, so many things to talk to? And for us, what we've been doing is perfecting the art of data distillation. And that's essentially not trying to train AI models on a bunch of raw data and math and all that fun. It's pre-distilling the metrics that come in and the information that comes in and saying, this is a footprint of the signal that is trying to be conveyed. This is what the signal is trying to say, the anomaly aspect of it, the seasonality of it, what's normal, what's not. And by having a footprint that small, what it unblocks us from doing is providing potentially unlimited historical context to these agents in a way that just feeding them raw data does not work today. So we do the distillation, we do the analysis, we feed that to an agent, we teach it what's unique to you. And that's what unblocks the possibility of you having a real observability co-pilot that can answer your questions, generate visualizations on the fly, help you figure out how to monitor, but more importantly, help you figure out how to prevent incidents, how to identify them autonomously without the need for hundreds or thousands of alerts, how to diagnose them and remediate them long-term in a completely autonomous fashion. And that's the vision we're building towards at Ottermon.
Well, thank you so much for coming to talk today, Checo, about this. I think it's fascinating. It was a really good conversation. I enjoyed that a lot. And I also wanted to thank Amin Astani for introducing us. What was it like working with Amin?
Amin's one of the most brilliant people I've ever met. He was, when I started at Acquia, he was the yin to my yang. He was the head of operations. I was trying to automate support, and the two of us had to work together to get the ship running in the right direction. And he's just absolutely brilliant person. Another one, just like you and I, he just wants to go out there and improve people's quality of life. So,
and I know we've only touched on a few topics today and not been able to go into the details some people might want to. So what I'll do is there will be a link to both Ottermon AI and to Checo if you want to contact him, reach out, in the description of this episode. But otherwise, thank you once again. Hope you had a good time.
Oh, absolutely. I can't wait. I'm already looking forward to the next conversation, Stephen.
And to everyone else out there, hope you have a wonderful week, and I'll see you next time.
Bye, everyone.